All right, this is lesson 1-2, which is modeling growth and decay in Algebra 2. So before we start, there's, as usual, a couple terms to define. They are depreciation and appreciation. So depreciation is a decrease or something that loses value. This is going to go down. Appreciation is the opposite. That's up. This is something that gains value. There's also something called the u sub zero. This is called the zero term. And what this is the starting value before any time has passed. We often use the zero term when we talk about money. So when we talk about money, we're often going to start with the zero term. Then we need to discuss what a common ratio is with appreciation and depreciation. So we've talked about common ratio already, but when we talk about appreciation versus depreciation, so appreciation is something that gains value. So if you want to pause the video really quick and set this little table up, that's maybe a good idea. So if you pause the video, set this little table up right here. Appreciation, when you calculate the R value or the ratio, what you're going to do is take 100%, which is 1.0 as a decimal, plus P, which is the percent as a decimal. That's going to give you your R value. Over here, for your R value, you're going to do 100% as a decimal minus the percentage as a decimal. And again, keep in mind that P is the percent as a decimal. Now, one thing that as I taught this unit, one thing that seemed to make a little more sense to some students was to take 100% plus the percent that it is gaining, and then divide that by 100. Okay, that's going to give you the same thing, but it just made a little more sense to them. So over here, it would be 100% minus the percent you lose, not as a decimal, divided by 100. Again, it will give you the same thing. So for example, if you gain 6%, you could do R equals 1 plus 0.06, which is 1.06. Or what I told my students is you can do 100 plus 6, which is 106, divided by 100, which is also 1.06. Okay, so you get the same thing either way. It just depends how your brain works. Over here, if we lose, 5%, the way you would calculate your R value is R equals 1 minus 0.05, which is 0.95. That's your R value. Or if you prefer the other method, you would do 100% minus 5% divided by 100, which is 95 divided by 100, and you get the same thing. Okay? Now, compound interest, this is a kind of an interesting thing. It's good if you're talking about an investment, but it's bad if you're talking about a loan. This is when you earn interest on the principal and the interest. So it's like getting money on free money. Or with debt, it's like getting debt on your debt. So we'll look at more examples of this when we go into the, I believe it's the second or third example in the notes. Okay, so before we start, let's calculate some R values. So 2% growth means plus. So what we would do is either 100% plus 2%, which is 102, divided by 100, which is 1.02, or R equals 1 plus 0.02, which is 1.02. Okay, so either way will work. Next one, a decay or a loss. This means minus. So you're going to do 100% minus 5% divided by 100, which is 95 over 100, which is 0.95. Or you can do R equals 1 minus 0.05, which will give you the same thing. Next one, this is growth. So again, we're going to do plus. So we do 100 plus 3.45 over 100, which is 103.45 divided by 100, which is 1.0345. Or 1 minus 0.0345, which, oh, sorry, that's plus. It's growth, which is 1.0345. And then last is a decay or loss, which is minus. So we're going to do 100% minus 31 over 100, which is 69 over 100. 0.69 is your R value. Or you can do R equals 1 minus 0.31. So 0.69 is your R value. All right, so I'm going to pause the video so that we can go through the last two without being too terribly rushed.